Hello and welcome to this RapidMiner tutorial. In this video, we'll show you how to fully automate your model selection and parameter optimization. We will start with the process we created in the parameter optimization video. As always, if this is the first video from our series which you're watching, then you can download the process and the data used here from our website. The video on data loading via process will show you how to import the data and the processes. Now back to our process here. In this process, we are optimizing the parameters of a decision tree algorithm. But during the tutorial on model selection, we saw that also random forest and gradient boosted trees are performing well. On this example set, if we were to optimize the parameters for either, then one of them might actually perform better than our decision tree. To try that out, we could now swap out the decision tree here in our cross-validation manually. But that would not be very elegant, as we would need to repeat this and reconfigure the optimization each time for any of the algorithms we are testing. So a much smarter approach would be to leave this one as is and use copies to create one parameter optimization with random forest and one with a gradient boosted tree. We will jump right to the end of this copy and pasting with the help of video editing. As you can see, we removed the log operators here and have also updated the parameters which we will use to optimize for the random forest. For example, we choose to iterate over the number of trees for the random forest and minimum split improvement for gradient boosted tree. We chose only one parameter to be changed, and we specified only 10 steps for each as we want to keep the time of our demo process to run very short. In a real case, you should consider doing a wider and finer selection, but keep in mind that the process may take some time to finish. By the way, there's also parallel execution available, which gives you a lot of boost as it uses multiple cores on your computer at the same time. Now, if you want to perform all three optimizations on our data, we could achieve that by using the multiply operator. Then we would need to look up the performance for comparison by hand, which is again not very elegant. After all, it is our goal to find the best model after optimization in an automated fashion and to automatically return the model with the best result. We will use yet another optimization as a varying parameter. It'll have to iterate over the 3 parameter optimizations, which we can execute using the helper operator, select subprocess. Let's do this. We drag in the select subprocess operator from our operators panel into the process panel. Then we cut the parameter optimizations, and then we paste them into these subsections using, for example, the right mouse button. Since we have 3 optimizations to trigger, let's add one more selection window. Next step is to connect the operators. And now we can embed this nicely into another grid optimization operator, which will then return the highest achieved performance of either of the embedded parameter optimizations. To make sure we are not only getting the performance vector, but also the info on which model was selected, we can also connect the parameters put here to the results. Of course, before we now run this automated model selection, we need to specify what to optimize. As mentioned before, the varying parameter this time is a subprocess and not a parameter per se. Therefore, there's only 1, 2, 3 here, as we have 3 optimizations as subprocesses, and we will do those in 3 steps. All right, before we run this process, let's reactivate our multiply and compare rocks operator in our main process, so we can visually compare the rock curves of a decision tree, random forest, and rule induction model, respectively. And in order to make sure all of our models present in this operator receive the necessary optimized parameters, we need to add another operator that performs an action automatically. So to do that, let's go back to our process, and then inside optimize parameters, and then select subprocess. Now we will add another operator called set parameters that applies the set of optimized operators to a different operator. In our case, that operator is a model operator that is being used to generate a rock curve. In the parameter settings of this operator, we can specify the name of the operator to which we are assigning this model's parameters. we can perform the same steps for the other two models as well. Back to our main process. And before we run it, let's take a quick look if the sequence of execution is right. Yep, everything looks good. We have our customer data, followed by filtering examples, and then that data is being fed to automatically optimize the model parameters. And then those parameters are fed to compare rocks operator to compare the model performance. Let's run the process. And finally, after a few seconds, we see that the best performance achieved by one of our 3 parameter optimized models is roughly 85%. And the model with the best result was in the subprocess 1, which is the decision tree. We can also see our rock comparison graph showing the curves of our optimized models. It shows that the decision tree model is the best model. But now we can see that the gradient boosted tree and random forests are close second depending on the threshold setting for the classification. To learn more about the interpretation of rock curves, please refer to the model selection tutorial in our Getting Started series. With this, we conclude our video on more advanced optimization techniques.